Hi class, today we are doing section 4.5, Inequalities involving quadratic functions. And on our notes, I have a few rules that I pulled straight from the textbook. But I want to talk about these rules in reference to our functions. And there's some questions that students seem to have a lot. And so I'm just going to write our quadratic equation as f of x. And I'm going to say, what if f of x is greater than 0? And I want to remind us that f of x is a substitute for y. And so what I'm asking here is, when are my y values greater than 0? My answer is going to be in x values. And this is really confusing for a lot of students because we're asking about the y values and we're saying the answer is in x values. Let me draw a graph so then maybe it might be a little bit clearer what's going on. Let's say that we have this quadratic function and I'm asking, where are my y values greater than 0? Maybe it's a little bit more obvious here, but my y values are equal to 0 when they are at the x-intercepts. But my y values are going to be greater than 0 or positive in this region. Does that make sense? I'm looking at the y value saying all the y values here are positive for this portion of the graph. Now the question goes, when does that happen? Well, my answer is going to be, it happens on this interval on the x-axis. And hopefully it makes sense why we're saying, hey, my y values are positive. What is my x values? And so then we're going to answer x values in an interval. For this question, since I asked when are they positive, I'm not going to include my endpoints. Let's just say my endpoints are 1 and 5. Well then, I'm going to say for all my x's between 1 and 5. And my answer in interval notation would be 1 and 5. And that interval between those two numbers. Let's do a very similar equation, but this time with an inequality symbol being slightly different. So the question now asks, what happens if my function is greater than or equal to 0? Remember, that means when is it positive and when is it 0? And so we want to look at this graph. We're going to do the same thing. I'm going to draw the regions at the x-intercepts where it crosses, and I want to look for the regions that are positive inside. So that would be this region. So I want to go in between my two endpoints, but also I want to include the zeros. So I'm going to include these answers as part of my answers. And so my interval is on the x-axis where it pertains to the positive and the 0 values. And so it's going to go from 2 to 8, but I'm going to include the 2 to 8 this time. So my x values are going to be between 2 and 8. This means at all the positive regions. But I'm going to include the 2 and the 8 because I know it includes the zeros. And so I'm going to have an interval from 2 to 8. And so our brackets, our parentheses will depend on the symbol in our inequality question. So for question number 1, it's asking us to use the figure to solve the inequality, and that's sort of just getting us in the correct mindset that we're comparing y values. I want to compare the y values of the f of x function, which is drawn in blue, and I want to compare those to the y values of the g of x function, which is drawn in purple. And so we're going to look at where are they equal to each other first, and that's always the first question. And so we're going to say, you might not have to write this down, but you have to identify where is your f of x equal to your g of x. They're equal to each other at x equals -3 and at x equals 1, right? Because that's where they intersect. And so we're going to look at that as our y values being equal. Now I'm going to compare. Once again, the question says, where is my blue graph less than my purple graph? And that would be the blue graph is higher than the purple graph inside these intervals. But you can see maybe we're talking about these regions over here, where the purple graph is greater than the blue graph. And so then the question is, on what x values are these intervals that I've just graphed? So my answer is going to be for the intervals here. And I'm not going to include my endpoints because at the endpoints, those functions are the same values. And I was asking when f of x is less than g of x, not when f of x is equal to g of x. So I know from looking at this, that would be from negative infinity to negative 3. We decided already that we're not going to include the endpoints. And then that's also going to be from 1 to infinity, not including the endpoints on that interval either. So another way we could state this is algebraically. We say x is less than negative 3 or x is greater than 1. But I'm just doing this because I want it to be clear where answer should be about our x values. And we should always know how to write it in interval notation. And so we have an algebraic notation on the left, and we have it in interval notation on the right. And you should be familiar with both notations. So for question number 2, we're given an inequality in algebraic form. And first thing I want to do is solve this the same way I solved question number 1, in graphing form, so that we can make some relation between the steps when we were graphing versus the steps when we're solving algebraically. And the first thing we did was graph x squared plus 8x, that's the left-hand side, and then we want to compare it to the right-hand side, which says 0. So we're going to compare that to the graph, which is y equals 0. In other words, the x-axis. And the first thing we did was find out where they're actually equal to each other, also known as find the intercepts. And the intercepts are at x is equal to negative 8 and x is equal to 0. Once again, we're finding when their y values are equal to each other, we're finding out which x values that happens. The next thing I said was to imagine that we had regions delineated by these two x values, so that would actually break up our graph into 3 regions. And you can see those 3 regions here in between negative infinity to negative 8, negative 8 to 0, and 0 to positive infinity. And the question is, which of these 3 regions, if any, satisfy the original inequality, which says x squared plus 8x is greater than 0. And so we're looking at when our parabola is greater than the x-axis, and that would be on the outer regions. And so when we see those outer regions, we were going to say those 2 regions are going to be where our solutions are. And we're not going to include when the y's were equal to each other or at the intercepts, because our y value was not greater than 0 at the time. And so you can see from our graph and from the regions that we put on the graph, we came up with our solution set in interval notation based off of this graph. We're going to solve this inequality. The first step we had to do was make them equal to each other. So we had to make it into an equation. And then we're going to solve this equation by factoring. And once again, what we're finding by setting it equal to 0 is we're finding the intersection points. And by finding the intersection points, that's going to take our number line and divide it into 3 regions. So we're going to put the negative 8 and the 0 on the number line. We're going to realize that we have 3 regions. And we're going to take test values in each of these regions, because we don't have a graph to compare it to. So I'm going to take the test values x is equal to negative 9, x is equal to negative 1, and x is equal to 1. Now I want to reiterate that these values on the number line are x values, but that when we plug these x values into our equation, we will get the y value as equal to 0. Now, what's the y value when we plug in negative 9, negative 1, and 1? I'm going to do the work quickly on the side. As we can see, when we plugged in -9, we got a y value of 9, which happens to be greater than 0, so it does make this side true. When we plugged in x equals -1, we get a y value of -7, which is not greater than 0, so it does not satisfy that inequality. And when I plug in 1, x equals 1, I'm going to get a y value of 9, which is greater than 0, so that does satisfy the inequality. And so we do have the two regions which satisfy the inequality are the regions on the outside, but not the region in the middle. And we're also not going to include the endpoints because when y is equal to 0, that does not satisfy our inequality. And we're going to write that as an interval from -∞ to -8, not including the -8, union from 0 to infinity. Now, just want to go back real quick. I'm using y equals and x equals so as to not confuse you, and that's sort of in reference to the values on the graph. However, there is no such thing as y in our original statement. But I'm just using them to when we're plugging in a value versus the value of the function. Okay, so we can see that algebraically, as we follow the steps, we got the same answer as if we solve graphically. Now it's not so easy to graph every single equation, so we're going to follow the same steps that we did with the inequality, and we're going to solve the next question using the algebraic version of the steps. Now we can see that question number 3 really lends itself to solving algebraically because we don't really want to graph each of these equations that we have. So what I'm going to do first is write this inequality as an equation. And I'm doing this to find out when the left side is equal to the right side. That helps me figure out the boundaries between my regions. And I'm going to subtract 40x from both sides. And then I'm going to factor. Now you can use any method you want to solve this quadratic. And I'm just recognizing that this is a perfect square. And so I'm going to factor it. But like I said, you're welcome to do anything. And so what this really is 5x minus 4 squared is equal to 0. When I square root both sides, I get 5x minus 4 is equal to plus or minus 0, which doesn't exist. It's just 0. And so I'm going to get 5x is equal to 4. And x is equal to 4/5. And I only have one solution. Okay, so then we're going to put 4/5 on the number line. So I'm going to draw the number line. I'm only having one number on it. And so that means I have two regions. And so I'm going to separate these into two regions. Now let's just be a little bit thorough in our work. This is an x value here. And we know that when we plug in that x value, then we have what we call a 0. Now, like I said, we don't have any y values, but we're using that as a placeholder. What I want to do is take a value on the left side of this, such as x is equal to 0. And I'm going to take a value on the right side of it, such as x is equal to 1. And I'm going to plug that into the original inequality and see if it's true or not. So when I do that, I'm going to get 0 plus 16 is less than 0. And is 16 less than 0? No, that's not true. And then we're going to go to the right hand side and I'm going to plug this in. So I'm going to get 25 times 1 squared plus 16 is less than 40 times 1. So that's basically 25 plus 16 is less than 40. And so I get 41 is less than 40. Now that's not true either, so the right side's not true. So I have the left side is not a solution, the right side is not a solution. When I am at x equals 4/5, that's also not a solution because that's equal to 0. Well, that's when the left side is equal to the right side, and that's not what the question is asking for. So we can see then we don't have any solutions. None of the regions work. So I have no solution. So for question number 4, we're going to solve this inequality algebraically. But the first thing I'm going to do is rewrite the inequality so that we're comparing one equation to 0. And that we sort of have less to think about. And this sort of makes sense that we're going to think about this side as our equation, and we're going to set it equal to y, and then we're going to look at where y is equal to 0. We're going to go ahead and rewrite this as an equation. And that's a very important step because we want to find out where those zeros are. We don't want to say where are the negative regions. We want to say where is this equal to 0. Now I'm going to solve this by factoring. Now you might choose to solve this using another method, like using the quadratic formula, and that's fine. Whichever method you know best, that's how you're going to solve it. So then I'm going to get 3x plus 2 is equal to 0. So 3x is equal to negative 2. So x is equal to negative 2/3. And then I'm also going to get 2x minus 3 is equal to 0. So 2x is equal to 3. So x is equal to 3/2. And once again, after I solved it for where it's equal to 0, then I'm going to make my number line. And I'm going to put them in the right spot. So my negative goes to the left, and my positive number goes to the right. Don't worry if these are fractions. When we take numbers and we're going to plug them in, we're going to plug them in any number that we can think of, so we don't have to pick fractions. Now, these once again are x values. So at these x values, my equation is equal to 0. And that's important because right over here, my question says, when is it less than or equal to 0? So my equals to 0 are actually part of my solutions. I'm going to go ahead and fill that in now because we know they're part of our solutions. Now let's go ahead and take test points in each region. So those test points, I'm just going to choose numbers like -1. In here, I'm going to choose 0. And here, I'm going to choose 2. You can pick any numbers you want, and I'm going to plug that in. So when we plug -1 into this portion of the inequality, we get 5, and is 5 less than or equal to 0? No, it's not. So this is not going to be part of our solution. And then when we plug 0 into that portion of the inequality, we get -6. -6 is less than or equal to 0. And so that is part of the solution, so I'm going to shade that part in. This region is part of our solutions. Let's try the next region. And when I plug in 2 into that portion of the inequality, I get 8. Is 8 less than or equal to 0? No, it's not. So this part is not a solution. So we know that the middle region is part of the solutions. We know that the endpoints are part of the solutions because the endpoints are equal to 0, and that was part of what the question asks. And so I'm going to say my region is -2/3 to 3/2, including the endpoints. Okay, so don't forget you have step 1. You need to make this inequality into an equation. This is really, really important. That's step 1. And after you do that step, then you can do your number line. You need to draw your regions onto your number line. That's your second step. And then your last step is to test each region by finding one test point in the region to see if it makes that inequality true, and only submitting the regions which make it true as your final solution. So there we go. And go get some practice in the homework and make sure you follow these steps on the test. Thank you.